In this lesson, I'm going to do one question on piecewise defined functions. So first of all, the piecewise function is when you have more than one functions given, which is different in different domains. So for example, here, f of x is x minus 4 when x is greater than or equal to 3, and f of x is negative x minus 2 whole square when x is less than 3. So you have the function which is linear when x is greater than or equal to 3, and you have quadratic when x is less than 3. So the question, the thing which you have to do here is find the value of f of negative 1 first, f of 0, f of 3, and f of 5. So when you are answering these things, you need to choose the correct piece for the values for which you have to find f of x. So for the first one, f of negative 1, so I have, if this is 3, for greater than or equal to 3, I have linear, and for less than 3, I have quadratic. So now for this one, when you are finding f of negative 1, since f of negative 1 is on the left hand side, which means for this one I have to choose the function negative x minus 2 whole square. So when x is negative 1, so negative 1 minus 2 whole square, which is equal to negative 9. For 0, again it's less than, which means when you have to again choose the quadratic one. So when you substitute, this gives you negative 2 square is 4, so negative 4 here. For f of 3, we will choose, because linear is included when 3 is included as well, so x minus 4, so 3 minus 4, so this is negative 1. For f of 5, again, is greater than 3, so we'll choose linear, which is 5 minus 4, which is also 1 here. Now, next thing is we have to sketch this function and then find the domain and range. So to sketch the function, normally what I do is I look at the pieces are given for which domain. Like here, the common thing is that this one is quadratic factor we have is for less than 3, and linear is greater than or equal to 3. So 3 will be my reference point here. So I'm going to draw a dotted line here for x is equal to 3. And when you are sketching it, maybe the values which you already found can help you. So we know f of 0 is negative 4. So that I know that if x is 0, I will have negative 4, so I will use that point. And then I also know for f of 3, you have when x is 3, y is negative 1. So I'm also going to use that value, so here. And for this one, it's linear, above, like greater than 3, right hand side. So the function is x minus 4, which means the slope is 1. So if I go one step up and one step right, so the equation for this one is going to look like this. It's a sketch, so we don't have to worry more about it. And the another information which I would like to see here is, because we know it's quadratic factor and it's negative in front of x minus 2 whole square, which means for negative x minus 2 whole square, this is going to be opens down. We know that. And we also know the vertex is 2, 0. So I'm going to sketch that. So 2, 0. And then if you draw, so this is going to be, this one is going to look like something like, for x is equal to 0, y was negative 4. Okay, we got that. And for x is equal to 3, it was negative 1. Sorry, this was not 1. So it should be x is equal to 3, it's negative 1. So this point should be here, not here, sorry. Okay, so this should be like this. And then you have this like that. Okay, so this is the sketch. And from this sketch, okay, so be careful. Like, don't do the mistake which I did right now. So when x is 3, your y is negative 1. And whereas for this one, I did x is 3, y is 1. So it should be this one. And now for this one, from the graph, it is easier to find domain and range. So x belongs to R is going to be your domain here. And for range also, you can see that it's taking positive values of y as well as negative value of y. So y belongs to R is also a range in this case. So that's it for this lesson.